Okay, so we're back with the time flies data, and I'm going to take a look at a test of proportions and the chi-squared test. So often with experimental data in particular, we are interested in knowing if our two groups are comparable. Is it a fair comparison? And something that we would want to know if we have actually allocated a condition is, does the allocation appear to be fair? Because if there's a problem in the allocation, then it makes it more difficult to trust the results. So we could have a look just at the condition eyes closed, eyes open. And the instruction was to toss a virtual coin online, and heads was eyes open and tails was eyes closed or something like that. So we could look to see if that worked out, because it's always possible that people will completely ignore your instructions and just decide for themselves, I want to do this condition. In which case, if that happened enough, we would potentially see that bias in the data. So we could look at this with a bar chart if we're just looking at the condition itself. And let's close up some of this data so we can see it. And it looks pretty good. It's not exactly 50-50, but honestly, if it was exactly 50-50, that would make me more suspicious than if it wasn't. So that looks fine. We can run a test for this. Now, this is just one variable, eyes open, eyes closed, and we want to know, could this have happened by chance if the true probability of being eyes open was 50%? So tossing a coin, is it fair? So we can do this under the frequencies option. And we've got a one sample proportion test. We've only got the two outcomes, eyes open, eyes closed. To me, it would be better if they worded this as two categories or two levels, because outcomes is often used for outcome variables. So I feel like the wording is not brilliant here, but this is what it means. The two outcomes within the one variable, so the two levels. So the condition is here. Now, you don't have to test that it's 50-50. That is what we want to test here, but you could change this test value if you were expecting a different proportion. So sometimes we do have experiments where we want to allocate more to one condition than another, so we could do that. And our alternative hypothesis is that it's not equal to 50-50. We can also get the confidence intervals out. So you'll notice that it's kind of doing the test twice, and it is a little bit redundant in that if one proportion is 50%, then the other one kind of has to be 50%. So I don't think it's necessary to do it twice, but it does. Our two proportions are 0.53 and 0.47. And because it is basically the same test, but one is the reverse of the other, the p-value is the same. So it's essentially one test with a p-value of 0.64. So we have no evidence that there is an unequal allocation or that there is some bias in the allocation. And our 95% confidence interval for the true proportion of eyes open or eyes closed, well, let's go with eyes open, is 0.43 to 0.62, and then it's the reverse for eyes closed. So if you were writing this up, you would not need to write both those lines up. You would just pick one, because the other is simply the reverse. And I would probably, honestly, I don't think it matters in this case. You could go for either. If one condition was more interesting than the other, or one was very clearly the intervention, the other control, then we'd probably report the intervention condition. So I guess in this case, probably the intervention condition is the closed, and then the default is the eyes open. So maybe we would report the proportion for eyes closed. And then the last thing to say is that this is, if you have a look at the top of the test, it is actually using what we call the exact test. So it says binomial test, whereas in class we have been learning the normal approximation. So the normal approximation is much easier to do by hand. If you have a computer to do all the calculations for you, then it can quickly zip through and do it using the binomial distribution. So you may get very slightly different results with the normal approximation, but overall it should be, broadly similar. Okay, so the next thing that we can test is, was there any bias on the different tutorials? So did we get this? We've got the even split overall, but did we have an even split in each tutorial, or did something go wrong and all of one tutorial did eyes open and all of a different tutorial did eyes closed? So the way that we can test this is by day of the week. There were actually several tutorials on one day, so it's probably not a perfect way to test it, but we didn't record the class numbers, just the day of the week. So what we're actually testing is there a difference between the condition and the day of the week. So probably more a difference between tutors rather than tutorials, because for the most part, there were 2 tutors on Monday, 1 tutor on Tuesday, 1 tutor on Wednesday, 1 tutor on Thursday. So almost a test of tutors. Okay, so we've got 2 variables now. So if we go back up to the frequencies, we're interested in a contingency table. This might be helpful if they said 2 sample or 2 variables, but cross tabulations, 2x2 tables, contingency tables broadly mean the same thing. 2x2 refers specifically if each variable happens to have 2 levels, which does happen a lot, but you can have more categories. We are not looking at paired samples, we're only looking at independent samples. So this is the only test that we need, and it's the chi-squared test of association, also called chi-squared test of independence. And if we were testing a set of proportions against some theoretical set, then it would be the goodness of fit test. But behind the scenes, the chi-squared test works the same way, where we're comparing observed values with expected values. So let's click that. Mathematically, it doesn't make any difference which way round you do your rows and your columns. Sometimes it makes more sense visually when you're looking at it. So what would I like in my rows? Probably easier to have the day of the week go in the rows, just because it's easier to read down than across. And then I will put the condition in the columns. Now it's just run the chi-squared test for us without us even asking, which is always nice. We have the null hypothesis is that there is no association between condition and day of the week. So that means there's no difference in the proportion of eyes open, eyes closed over the different days of the week. We have a high p-value, so there is no evidence against that null hypothesis, and we will assume in this case that there is therefore there's no evidence of any bias in the way the experiment was conducted. We can do so in the cells, if I just take a look at this contingency table first and then we'll do a plot, we can get the expected counts. So if you want to practice calculating expected values, and obviously the examples and formulas are in the notes, this is a good way to do it, because you can have a go at doing some of them and then get it to run the test for you, or you can have all these expected values calculated for you and then you can check that you know how to use them in order to get the test statistic here. Other packages will also give you more details about the differences between each, the errors or residuals and that sort of thing. This is a very sort of restricted look. So if you have experience with another package, you may be used to more options here about the things you can display. If you want the percentages, and that may actually be helpful. Oh, it's doing them for each one. I was going to say, if it just gave you the percentage here and the percentage here, that might be nice. The problem with showing all the information is that it just really clutters it up, and it makes it quite a large table. So I think that will do. Just going to check what the options are here. Okay, so we're not really going into odds ratios or anything in this course. We don't need any of these. The only thing that you might come across is the continuity correction, and this is specifically for if you have a 2x2 table, and it's just a very picky little thing that some people say you need, but then there's also whole papers written on why you don't need it. So in general, I wouldn't worry about it. And they also have the z-test for a difference in 2 proportions, which I've just noticed. So if you were doing this by hand and you wanted to check it, you could potentially do that here. I feel like there's easier online calculators for checking for a difference in two proportions than doing that one. Okay, so the last thing that we'll take a look at is just how to do a nice bar chart. Lots of different ways you can do the bar plots, bar charts, don't mind which one you do, say. And sometimes it just takes a little bit of playing around to decide which one is showing what we need it to show. And it can be different for each problem. I'm going to put down my pointer. So I think I would prefer the stacked. I think that is cleaner to compare. Stacked is difficult if you have a lot of categories, unless you're color coding the categories with a gradient, say from strongly agree to strongly disagree. If there's a nice gradient to it, then it can be okay to have several categories stacked. Otherwise, it can look like a bit of a mess. We don't have any really small sample sizes, so I think, but they are unequal. So I think these would be easier to compare if they were percentages. However, we do have to check that it's doing the percentages the way we want. So it says within rows, and our rows here are the day. That doesn't look right. I think this is not lining up correctly, but anyway, within the column, oh, it is within the rows. It was showing within the rows, but I think it might have done within the total. Interesting. So make sure you click through that to check that it is doing what it says it's doing. So within the rows means within the day of the week. So it's saying within the Monday, what is the percentage of eyes open versus eyes closed? And it's eyes open was, I don't know, 40 something, and the eyes closed was 50 something. So and then this is hovering around the 50% mark. But there's no evidence of any bias. Statistically, we don't have any evidence that this proportion is different over the days of the week. So I feel like this is probably the most intuitive way to display this data. It probably wouldn't look so neat if we did it the other way around. So if I did condition in the rows and then the day in the columns, you can see that suddenly it gets a lot messier. And this is more difficult to understand. Yeah, I don't think there's any good way to show that, have the counts. So for whatever your data is, if you have this type of data in your project, you might just have to play around with what makes the most sense. Okay, now it says total within the rows. And you might just have to have a play around for what makes the most sense for you. Oh, look, I could have switched it here. There you go. So you can switch these around. I mean, that's okay too. I don't know, I think I have a bias towards stacked graphs, but that one works, I guess. So you can play around with these and work out what is best for your particular data set. And obviously you can change the colors with the color scheme. So again, these have a very similar color intensity, which means depending on if you have color blindness and what type of color blindness you have, that can be difficult to see. So if you're going to have colors, don't rely on the color to be the only signal for what's different. You need to vary the intensity, or you can add a texture to one of them. I'm wondering what theme that we have here. I have a feeling that they all have similar intensity colors. That one may be better. I don't really like it. Oh dear, gosh, goodness me. Oh God. Okay, so this is boring, but it's actually good because we can clearly see the difference. So I don't know who came up with these color. It would be nice if we could do a little bit more with the colors in Jamovi. Okay, so it looks almost like an Excel chart actually with these default colors. Yes, it does. I think someone did a color picker on Excel and got the same colors as Excel. That's okay. So that I would go for a color where you have a difference in the intensity of the color. And then even if someone is colorblind, they should still be able to see one is darker than the other and interpret the graph. Okay, that's far too much fussing about with graphs. I don't think anybody cares about color theory except me. But yeah. Okay. Have a good day.